Okay, recording.
All right. Let's go. Now, I've said before that logic is about relation, but logic also has some weird things about it. Namely, it has its own set of linguistic devices. Now, there are different ways of doing logic, and each one has its own set of particular ways of saying or representing statements, premises, conclusions, operations, the whole thing. But for now, we're going to focus on some informal syllogistic logic. Now, in syllogistic logic, we have to distinguish between different kinds of categories. There are general categories for larger classes of things like cars or babies. And these classes we represent using capital letters. So I would write like babies. But if I were to talk about, say, a 1991 Arctic White Ford Escort hatchback, which was the first car I had, then I would represent that with a lowercase letter. Like so, right? This is really just for making sure that we don't get things all confused and that larger classes and smaller classes, general classes and particular classes aren't really mixed up. Now there are 5 major terms that we use, or operators that we use in informal syllogistic logic. All, no, some, is, and not. And we put these 5 words together to compose what some people call well-formed sentence formulas, or WOFs. It's an incredibly stupid name. I just call them the right way to do logical statements. But why are they the right way? Well, they're the right way because they allow us to unpack the relationships between terms and premises and conclusions in any informal argument. Arranging everyday idioms into standard logical syntax saves us a lot of extra time and a lot of extra cognitive work, and it allows us to demonstrate the relationship between all of the parts. Now, there are 8 standard forms for logical syntax in this informal way. We're going to focus on the first 4 of them, namely, all A is B, no A is B, some A is B, and some A is not B. Take the sentence as an example. Spider-Man is a human being. Now, we can represent this 2 ways. First, we could say that Spider-Man is a general category. For example, there have been multiple Spider-Men, Peter Parker and Miles Morales being the most notable of them, although there have been others. And thus we treat Spider-Man as a general category and say that all S is H, right? All Spider-Men are human beings. So I would represent all Spider-Men are human beings as something like all S is H, right? It'd be one of these statements here, right? And that would be me classifying all Spider-Men as properly human. But if you think of Spider-Man as an individual person, like it's only Peter Parker, it's only Miles Morales, then you would represent it in a different way. You might represent it sort of like this. Right? Not all, because it's not a general category, it's just one person. The differences between these kinds of statements, we'll discuss them later, maybe. But for now, let's make all of our statements about general classes. So now that we understand the kinds of formulas or sentences that are most appropriate for logical statements, we have to put those statements in the right order in order to reach a conclusion. When we organize our statements in the correct order, we say we have a syllogism. Right? Now, a syllogism is one or more logical statements in which each letter occurs twice and the letters form a chain. Well, whatever that means. So, why don't we try an example? So let's take this example. No pure water is burnable. Some river water is burnable. Therefore, some river water isn't pure water. And we can represent this in the following way, right? No P for pure water is burnable. B for burnable. Some river water is burnable. Therefore, some river water is not pure water. So we have a syllogism, but how do we determine whether it's valid or invalid? Well, luckily for us, the author of our textbook has developed a system for determining the validity of a syllogistic argument. This is a method of evaluation that he has called the star system. Before we talk about Gensler's star system, we have to talk about distribution. Distribution is concerned with how strongly a term relates to its class. So if I used the example, all unicorns are hooved creatures. Here's my lovely unicorn. The subject unicorn is distributed because each and every unicorn is included in that statement. The predicate, second part, the predicate or second part is undistributed because not all hooved animals are unicorns, right? Cows, regular horses, donkeys, I don't know, centaurs, they're all hooved animals, right? We'll get into the nuts and bolts of what distribution means in a later video, but for now, you're gonna have to memorize it. It sucks, but you have to memorize it because otherwise you're not going to be able to do the star system, and Gensler is going to be pissed, and he's a Tron villain clearly with a name like Gensler, so that means that you can't use a computer anymore because he's coming for you. But that's all besides the point. So I've developed this handy little chart here for you to understand what is distributed and what isn't distributed. So with all statements here, the subject, the first term, that is distributed. But the predicate term is undistributed. Why? Because the amount of sway that the class in the subject has is stronger than that of the predicate, right? In no statements, both are distributed. In other words, it is not the case for this and not the case for this, right? It's equally distributed, equally holds sway. But in a some statement, right, some horses have shoes, for example, right? Both terms are undistributed because it's rather ambiguous. Whereas in the some are not statement, the subject is not distributed, but the predicate is, because you're able to say more of the predicate than you are of the subject. All right, so here's an example syllogism that we'll go through with the star system, right? All A is B, some C is A, therefore some C is B, right? The first step we have to do is figure out which terms are distributed, right? So we underline those terms. Well, we know that the subject here is distributed, so that means that we underline the A. But if this is a sum statement and this is a sum statement, then we know that they're both undistributed, so A is the only one that we underline, right? So the next step we have to take is to star things, and we have to star appropriately. We star only those terms in the premises that are distributed, so in this case we star A. And then only those in the conclusion that are undistributed, which is C and B. All right? So then finally, we count the stars. All right? The argument is valid if and only if every capital letter is starred one time and one star is on the right side. So every capital letter is starred and it is starred once on the right time, or on the right side. Every capital letter is starred and it's starred once on the right side. Now, if this were a sum or not statement, then the argument would be invalid because you wouldn't have a star here. This is a quick way to understand which arguments are valid and invalid if they're already in a syllogistic form. Now this method is good for simple syllogisms like the one we have here, but it's not that helpful when we get into more difficult aspects of logic. Speaking of which, translating sentences that begin with all, no, or some, that's relatively easy. But what happens when you have sentences that begin with more difficult words, when you have to translate harder idioms into standard logical speech? Well, to make this kind of transition and this kind of translation, we have to develop some new rules. So first, we have to be mindful that some negative statements are not easily translated into no statements. For example, if I were to say, no one is a Pokemon trainer unless they know every Pokemon, it sounds like I'm making a negative statement. However, the best way to translate that sentence is actually in the following way. All P. Okay. In other words, all Pokemon trainers are knowledgeable about all Pokemon. That's a much better way to say it than, no one is a Pokemon trainer if they don't know all the Pokemon. When dealing with modifiers like only and none but, you have to reverse the terms. For example, if I said only A is B or none but X is Y, I would have to reverse the terms to put them in standard logical form. In this case, it would be all B is A and all Y is X, respectively. Also, never use this phrase, all A is not B. It's way too ambiguous. If I said, all headphones are not yellow, I could mean no headphones are yellow, or I could mean some headphones are not yellow. And you can't tell which is correct. So this, way too ambiguous, don't ever use it. Finally, there are limitations to what we can say clearly with complex statements. So if I say, it is false that no libraries are fronts for drug cartels, how should this be translated? It should be translated as, some libraries are fronts for drug cartels. In like manner, if I said, it's false that all cars have AC, you would be correct to translate it as, some cars don't have AC, or some C is not A. We can only translate what is stated, not what we can claim about or infer about the statement. So there you have it. You learned about syllogisms and the star systems. You learned to do the star system right, otherwise your computer will come and attack you because the Gensler program is after you. You also learned about testing for validity and translating weird or complex sentences into concise logical syntax. And that's quite a starter pack when it comes to logic.